Hello, I am Md.Ahasan. I am working in the microfluidic device division lab under the supervision of Professor Sangjin Kim. So I am going to present a question and answer session about my previous presentation, I which I mentioned about autonomous oscillating PDMS PCR chip for detection nucleic acid analysis by using temperature gradient. So first question is about how can you control the PCR chamber pressure so that fluid can passes through the chamber below 0.8 kilopascal during annealing and extension step. So regarding the question, fluid can passes through here. So you see from here, there is two layers. One is top layer with gray color, and another is bottom layer with yellow color. So pressure oscillator flow comes from this direction and go out in that direction. In the meantime, it generates pressure here. So pressure is taken by using capacitance C1. You see that here C1. So this is the C1. So no fluid can passes through from the oscillator to that direction. It is maintained that oscillator pressure only can generate pressure both across the capacitance. So if the oscillator pressure is like this is x-axis, this is y-axis, P and T. If oscillator pulse is like this, the capacitor will generate same type of pressure. We can see from the figure 4 here, capacitor pressure is like high and low value. So almost same like oscillator. So it will make pressure, it will generate pressure -10 kilopascal to 15 kilopascal according to this model. So this pressure will force, this is the pressure across the capacitance like this end, this side, right side of the capacitance. So it will force fluid to go through this direction, and when the pressure is opposite, negative pressure, then it will draw the fluid in this direction. So by this way, it will oscillate in this device at figure 2. Next question is, how does the oscillator flow connect to PCR into PCR chamber? So it's also almost same question. How does the oscillator flow connect to PCR into the channel? So I mentioned last answer, that oscillator flow cannot pass through this direction. It will only transfer pressure at this capacitor. So left side pressure of oscillator is like this. So right side pressure also almost same like this. But in reality, it will not like this shape. In reality, it is very sharp peak. After the simulation, I get this type of result, but I don't have time to change this type of simulated result. So for this is the only theory. So only this type of pressure will create this type of pressure will create oscillating flow through this direction, and when pressure is positive, then it will go right side, and when pressure is negative, then it will go left side. By this way, the fluid will oscillate inside this PCR chamber. Next question is why I designed the height 50 micrometer. So this is the design mentioned by author. So they did not mention about the height. So when I calculating to make the flow rate same of both design, this is my design and this is author design. So to maintain the same flow rate, I thought about to make same length like 31.5 millimeter. Instead, I use almost same length, but to maintain same resistance, I change the value of width and height, but so that here width value is considerably changed from 100 micrometer to 1 micrometer. And as there is no mentioning about the height, so I don't know about what will be the resistance. But for my oscillator, I need to control the resistance of the fluid here, resistance of the channel here, because if resistance is not controlled, then the oscillation flow will be stopped anytime. So as it is an autonomous device, so I need to think about the this capacitance and the resistance, which will not affect the oscillation pressure. So for this reason, I was thinking about the height 50 micrometer and width 100 micrometer for my own design. And next question is, if on the diameter, maybe this should be width, is not be my diameter. If the width is this melting curve, not this is melting, this is channel, not melting curve. So if the width is 10x thinner, then what will be any backflow or turbulence here? So according this question, there will know, I will mention about the first part already. So I was thinking about the width 100 micrometer as my own choice, because I don't know the resistance of this side and this resistance of this device. So I designed my device like that so that it will not impact in the oscillation of the oscillating pressure in the oscillator. So for this reason, the width will be considered as 100 micrometer. In that case, it will not affect or oscillation, number one, and number two, there will be not backflow, because here is the capacitor. You see here capacitor, so flow is generated from the top side to here, and it never go to the bottom side, because they both are separated by a membrane. The capacitor is made by a membrane, so we know the pressure across the capacitor is same, so flow will never go back to the oscillator channel. And next question in figure 6, another question is, if width is 100 millimeters, so I design the width like this. This is 11, sorry, this length is 11 millimeter of my channel. So mention about this length. And temperature difference is 45 degrees. So will there be any interference between top and lower temperature? So definitely there will be interference between top and bottom layer. This area indicated here has some temperature gradient. So I need to overcome this type of temperature gradient. So you remember the pressure versus time. This is pressure and this is time. Oscillation, one is larger, sorry, yes, one is one time is larger and another is lower. And when the pressure, this is suppose pH and this is PL, when the pressure from top to bottom drop very quickly, less than 1 or 2 seconds. So fluid passes from, suppose this is region A, this is region B, fluid will stay here or here. So, and this is C and this is D. So when pressure goes from pH to PL, so very high speed fluid will passes from A and B. So it will not stay in region AB more less than it stay region AB less than 1 second. So the interference between top and bottom layer will not affect. In the same phenomenon will happen when will happen if fluid go from DBAC, opposite direction, like from D to C. So fluid will not stay region B to A less than 1 second. From here you see low pressure to high pressure. The fluid will not stay many large or long time here. So by this way we can avoid interference problem. Next question is, what would be the effect of shear force, shear resistance, shear stress, friction factor, and capillary force? So as this is a fluidic device, so I think it has effect of shear stress and friction factor. We know when the laminar flow happen, at Reynolds number, if less than 2000, there is laminar flow. And definitely the flow rate of the fluid is very small because is small. So flow rate, Reynolds number must be very small. We know the Reynolds number equal to rho v d by mu. So velocity of fluid is small, so Reynolds number must be less than 1/2000. So it is a laminar flow. If laminar flow occurs through a channel, then we can see that there is the sharp pressure parabolic shape of pressure profile happen. So at the wall, the value of velocity is 0 and the maximum in the center. So there we called it wall shear stress, and the here this is called no slip condition also. And so definitely there is some effect of the shear stress in the flow. And according to friction factor, there is some we know that my device resistance is very high from here to here. So when fluid passes through this large resistance, then there will be large pressure drop across this resistance. So there will be some effect of friction factor. But normally in microfluidics device, normally friction factor study is not carried out frequently. And about the capillary force, the capillary force, I think there is no effect because it is not vertical device, it is horizontal, and the force is driven by pressure from oscillator. So I think there is no effect of capillary force. The next question is, what is the main advantage of this device? So I already mentioned that previous device was this device was connected with the series pump. This series pump is computer programmable series pump. So now, so which required computer program, and so I remove this part to oscillator, which does not need any computer program. So it is autonomous device. This is the main advantage of this device. And another part of this question was, large amount of reagent is required to obtain desired pressure. The question who asked the question, he thought that large amount of pressure, a large amount of reagent required for desired pressure. I think there was no need of large reagent, because once we input PCR reagent inside this channel, then we don't need to change it before finishing the PCR reaction. So here flow is, here PCR reagent is given for one time, and it is used for several times before up to finishing the PCR reaction. So one thing is large amount of fluid is required. Maybe this large amount of fluid is required here, because this is input here in the oscillator. The input is given by water normally. So I think water is not very costly reagent. We can use normal distilled water for the oscillator. So water is coming from top and go to the bottom. So we don't need to large amount of reagent for PCR reaction here. The next question is, if the intensity, the temperature increase, the intensity of the device after some cycle later, it will increase. You can observe from this figure. The intensity are very brighter than this type of figure. So from this figure, the author said that the cycle number, this is cycle number 17, and this is cycle number 25. But according to my presentation, for cycle number 15, it should be more higher fluorescence than cycle number 17. I think there is some problem in the experimental condition. I think we know that this is PCR device. This is the channel, we know. I think they did not finish the experiment with same reagent, or they do cycling PCR cycle for suppose 1, 2, 1, 5, 9, 13 for by one device, and another device they do more cycling, like 1, 5, 9, 13, 17 cycle, and by another device maybe they use different device or different reagent of initial condition are not same. So I presented same plotting from another paper, that they have same fluorescence changes with this. They are similar, both of them, and the orientation of each curve are also similar. This is higher fluorescence, this is higher fluorescence here. So I think they have made some mistakes in the initial condition. And next question is, before incubation, we need before denature, we need 3-minute temperature for high incubation temperature. How we do it? In this case, what should I do, or what things should we change? In this case, we should do PCR reaction, heating at other device here for 3 minutes, and then put it here inside after connecting oscillator. Very quickly, this time should be very fast, less than 1 or 2 minutes, less than 30 seconds, so that the temperature will not lose, because at 3 minutes the PCR reagent will heat it up to 92 degrees centigrade. So 92 degrees centigrade will be there is temperature gap between atmospheric pressure, atmospheric temperature, and this temperature. So cooling will be faster. So in that case, we should do transfer very quickly from here to here. And next question is, if I use the in previous case, here I mentioned that 10 to the 10 and Now I mentioned 13 because it was designed according to 13. So I wrote in the Plex software wrong input. I gave wrong input. And then after correction, there will be any change or not. And if any change, how I solve it? This is the question. So I changed the value of Plex diagram. The previous result was like that. The maximum pressure was almost 13 kilopascal to 7 kilopascal. Now it's good, looks uniform. Now it looks uniform. It almost 15 kilopascal to 13 minus 13. Oh, sorry, this is minus 7 and this is minus 13 kilopascal. So after putting the accurate value, the graph will comes after simulation. It will be very good and nice. So thank you for listening my presentation. I am going to stop my presentation now.